Hi, hi everyone. Okay, so so let's go. So wow, we haven't had class in a while. So let's do it. Okay, so today what I'd like to do is finish up chapter two, and then um, we already did part of it, but I want to go through it. So I'm gonna get a drink, and I want to what I want to do is um, oh, am I recording? Yeah, I'm recording. Great. So what I'd like to do today is um like sort of okay, we'll start chapter two and I mean let's finish up chapter two. Okay. So let me hide this and let's do it. Okay, so um is here we are chapter two. So again, chapter two is dealing with it's like a very basic approach to to the whole idea of software engineering. It's basically it's speaking about that there's like three basic ways that you could solve a problem, right? And it's not even really specific to software, it's just in general, right? So what are the three basic ways? So the one way is that you plan everything out and then as you plan everything out, you do it step by step, but you only do what's called waterfall, which means that you are not going to repeat step like for example in this drawing over here, the requirements, you're not going to repeat it after once you've gone to the design phase, then you're not going to go back up to requirements. So you do it in order and you only do it once. That's the goal. Okay? Any questions? Let me make sure I can hear. Somebody home want to say something? I just want to make sure I could hear you. Uh, Not hearing anything, turn up volume. Oops, that's not, I wanted to, oh, I know. I have to do that. Sorry. I can make sure. Select speaker. It's probably this is the right one for display audio. I guess, could someone say something? I just want to see if hello?
Hello.
Oh, good. Oh, okay. Good. I heard you. Okay. So I want to make sure that I could hear. Thank you. Um, Anyhow, so the idea is there's three ways to approach a problem. One way is that you do a linear and you don't, after you do step one, you do step two, and then you don't go back to step one again. And then we have incremental where I'm just starting from the beat where we left off. So then we have incremental where we do a little bit at a time, but we're going through all the steps each time. So we're not just, so we're going, much different than here where we're doing each step once before we do the next one. We're actually doing all the steps over and over again. Okay. So we're doing a little bit at a time. And then the third way, I don't have um, oh, here I have the third way looks like this. I gotta make this bigger here. So the third way is called the reuse model, which is that basically we don't write new code, but we actually try to find existing code that does what we need to do because that is always the cheapest and the most efficient way to do things, right? Sort of like using AI, right? Like why write code when you can have AI write it for you? So, um, um, so anyhow, um, the problem is that you can't have AI write code unless you understand what it's writing. So it's not exactly as simple as it sounds. Oh, I have AI write something. Like today, I had AI do something for me, and m most of the stuff, the one bug that I knew about it found, and then the other things it did, there was like something really silly, and it didn't catch it. I was surprised. So. Anyhow, but the point is you have to understand what it's doing. You can't just have, have AI do it because it's just doing some code it found somewhere else and it's trying to put into your code. Okay, so so this is the reuse model. Now the reuse model basically says that um, um, that we're going to um, we're going to first decide what we want, right? No, it's before you use anything, right? So, for example, let's say I'm looking for a accounting system. No, actually, I'm looking for something free. So, let's say I want a scheduling program, right? So, I would go over here and I'd look up um, free scheduling software, right? And then I would 10 best project whatever, I don't know. Uh Calendly by put. So this would be why is it not free? Anyhow, the point though is that it Calendly, Google Google Calendar is free. Doodle, okay, whatever it is. The point is that I would look around at these things and see which one of these would do what I needed to do, right? What I need to do. So rather than write the software, I would I would look around and see if I could find something, right? That does what I need to do, right? So um, so there would be the requirement specification where I know what I'm looking for, and then I would look at different software and find out if they do what I want it to. Now, chances are you're never going to find something that's perfect, right? Because again, we're not writing it, we're just finding something that's already written and we're trying to reuse it. So most times when you're never going to find, most times you rarely find everything you're looking for, right? So it's always going to be some trade-off. So so that's why you notice it has this oval that says requirements refinement because we're going to have to probably change our requirements, right? Because when we looked around for software, we didn't find everything we wanted, so we're going to have to modify what we expect to find, right? Right, because for example, let's say I'm looking for a pre-built shower with blue tiling, you know. So probably if I go to Home Depot, they might have one with white tile, right? But not with blue tile. So I'm going to either have to change my mind about what color tile I want, or I'm going to have to do it myself, right? Because I can't buy it off the shelf, right? But so that's the idea of requirement refinement that I'm probably not going to find exactly what I'm looking for, but so I could either say, well, it's good enough, whatever I find is good enough, or I could say, there's nothing, I didn't find anything that I could reuse, so I'm going to end up doing it, um, I'm going to end up doing it by hand. Okay. And then after, and then this, and then once we finally found everything that I want to use, then if I found something, so I could either find a whole system. You see, that's the top arrow. It says application system available. So that would mean that I found everything. That's a whole program I could reuse. So then the only part I would have to do would be to configure it for myself, right? Because it's a general program, I need to set it up to use it for myself. Or if I only found some components, right? I didn't find a full program. I found parts of I could use. So then I could either, I either are going to have to, I'm going to have to adopt the components, and I'm going to also have to develop some new components and then integrate into my system. Because I didn't find everything. I only found a little bit. Like I found, let's say, a library that does graphics, right? Or, something like that. Or maybe I found the scheduling program, but that's only part of what I need my software to do. So I can integrate it with the rest of my system. Okay. So in general, the the reuse is going to be the best one, right? Because again, we said it's always going to be cheaper and it's going to, it's first of all, it might be free. Second of all, it's definitely going to, there's no development. So there's always, it works right away. So you don't have to test it. You don't have to write, you don't have to go through the whole painful process of developing software. So reuse is really the best way to do it. Um, now, now we're going to discuss the other two ways. It's where you can't find software. We'll go through it actually. Why sometimes you can't do software reuse. Um, Well, the most obvious reason is because you can't find anything, right? You still have a great idea and no one wrote code for that, or there's no free code for that. So you have to write it. So, um, okay. So again, um, what what do we need to do? So again, this is from chapter one, and these are the things that we're going to have to do with, however we do it. Either we do everything up front or we do little by little, we're going to have to do all these things, right? In other words, you're either going to have, you're always going to have to do requirements, you're always going to have to do design, you're always going to do coding, you're always going to do testing, and you're always going to deploy it. But the difference will be that depending on your process model, right? If you do waterfall, you start at one and you go from one through six and you don't go backwards, right? So in the waterfall model, we do steps one through six, and then the project should be complete. Meaning, like, for example, I wrote, like, let's say you put a cake in the oven, then you can't, it's already done, it's already cooking. You can't add sugar. You can't go back to the previous step, right? And also, we know when we're finished because we're going through all the steps in order. The incremental model, on the other hand, will say that you don't have to go through, you could go backwards. And so rather, we're going to cycle through two through five over and over again, right? We're going to do every month, we're going to do requirements, design, coding, and testing, and we're going to keep repeating it over and over again, constantly. So that would be the incremental model. And then the reuse model would would basically just do the first, it would do steps one and two, which we saw, right? You have to know what you're looking for, and then you would just go to six. You don't need the testing part because it's already been tested, the software, right? So So the reuse model would just do 1, 2, 6 only. Okay? Oh, the reason why I called integration and configuration, because that's what the book calls it. It's very confusing. Okay, instead of calling it reuse. Okay, so now now that we want to go through the models and uh, see what are the benefits and what are the in other words, why would I do waterfall? Okay, in other words, what are the benefits and what is the downside of using each of these models? Okay, because obviously, if it's still around, there's a reason we have it. Okay, so the reason to have waterfall is for an example, we said, I think we said it, but if we didn't, I'll say it now, that um, when software is when it's expensive for whatever reason, either because it's hardware, it's related to hardware, like embedded software, or um, uh, or maybe it's medical software, so it's expensive to have it changed. When you change the design, every time you change the design, you're going to have to it'll be very expensive. So that would be something where you wanted to do it, you only want to do the requirements once. You don't want to go back and change it because every time you go back and change your requirements, then what happens? Then you're going to have to, it's a very expensive process of you're going to have to either change hardware, you're going to have to need a new review by the government, and that might take a couple months to do. So, so basically, when it's expensive to change your mind, that's when you want to do everything only once. You want to do this, or you want to do the requirements just once. You want to do everything, the design once, right? Because it's very expensive to change. Okay? For different reasons, right? It could be expensive to change because it's dealing with hardware, and then if you change the software, you're going to have to change the hardware. That's what's called embedded software. Or it could be medical software where it's expensive in terms of time. Because every time you change the design of of the software, you're going to need to be recertified, right? Or let's say airplane software, again, has to be recertified, right? The government has to recertify it. So all these cases are where it's expensive to do it more than once. Okay, so that would be a reason why we would use the waterfall. This type of software, you can't just keep on, going more requirements over and over again, right? You need everything up front because otherwise you'll never be able to release the software. Okay? Does that make sense? Okay. Then you have a contractual reason why you might want to have the waterfall model, because the waterfall model, since we're only doing the requirements one time, so that could actually be the contract. In other words, if someone walks up to me and if I hire somebody, I want to have a contract with them, what are they going to do? Right? So if we're doing waterfall, the requirements could be the contract, right? Everything in the requirements, if it's not going to change, could be the contract. But if you're doing incremental, where it's the requirements could change, or you only have a little bit of requirements each time, right? Then what's the contract? What are you going to write in the contract, right? I agree to pay you $1 million for for what, right? If it's incremental, we don't know yet what's going to be there because we could change it, or we're going to do a little bit at a time, right? We haven't decided what's going to happen. So waterfall is better for it. I mean, most people want to know what they're paying for, right? So so for contracts, it's very good to have a waterfall because then everything is there. Another reason you might want to have waterfall is where is where if you have different groups working together, so then you can't have one group changing their mind or going back and changing their requirements, right? Because then it would mess up all the other groups. Like, for example, imagine you have, let's say, a big um, plane manufacturer, right? And they have one group working on the software for the wings, and one is, or even for a car, right? Cars have a lot of software in them nowadays, right? So one group is working on the software for the engine, one's working on the software for the headlights, one's working on software for, I don't know, whatever. There's a lot of transmission. So you can't just change the transmission software because without, it might mess up the people working on the engine software, right? So all this different softwares have to work together. So you don't want to, so waterfall might be a better way to do it because then you don't have to, but when you change, because this way everybody's on the same page from the very beginning. And you don't have to worry, well, this other group might change their mind, what they're going to do, and they're going to mess me up, right? So basically, what if when you have a large project with a large amount of people working together, so then you would want to do waterfall also because you don't want to change your mind later on, or you want to have everybody on the same page from the very beginning, right? Okay. What is the problem with waterfall? So, so number two is the real reason that we said it's the biggest problem is that because we remember we said, I know it was a long time ago, but we said that the problem with waterfall is it's hard to estimate how long a project will take, right? Because with waterfall, you haven't done any coding till you've already gone through you're waiting to do the coding. Um, where is it? It's up here, right? We're not doing the coding until we've done requirements and design. And so at that point, we're it's the first time we're doing development and testing, right? So, so, so what happens is, if there's a delay in development, right, it's too late to do anything, right? We're stuck because we already did the requirements, we did the design, and that's fully, locked away in the safe, right? And now we're stuck doing the development, but let's say the development takes more time than we estimated, right? So, because we don't know really how long the development takes, because we haven't done it. We only did it, we only did development after we did requirements and design. So we're sort of stuck, right? We're stuck to do the development and development might have problems, right? If it runs into problems, it takes longer than expected, which it always does, right? Then what do? Right? We don't have the only option we really have is to basically take longer for the project, right? Which is why you find like in the Pentagon, right, when they have these big defense contracts, they always take years longer than originally was planned, right? Because you're only, when you finally get to the development part, you realize, wait a second, this is kind of hard to do. This is new material, right? Anytime you're doing something new, it's going to take more time than you estimate. So that's why the main reason not to do waterfall is because you end up um, the project is probably going to run over schedule. Okay. Um, so that would be the downside of, that's the main and then also there's a reason why before they came up with incremental model, why many projects failed, right? Because they estimated it would take 3 years for the project, and after 3 years, the coding was, only, let's say, one third done. So and they need another 2 years. And the boss said, well, sorry, we don't have a budget for that. So they just threw the whole thing out. So, because it was worthless, because they only had 1/3 of the code. Okay. Um, Another problem, so this is the major problem, number two. The other problem with waterfall was that it doesn't allow for changing requirements once we start the next step, right? It's not built into it, right? So, um, meaning that even if you discover while you're doing it that this requirement, or maybe let's say facts on the ground change. For example, you have a requirement that, let's say your software has a requirement that has to print something out. But while you're doing the project, let's say it's a multi-year project, you realize that people don't have printers anymore. So that requirement, right, might not be applicable anymore. But you can't really change it because it's part of the requirements, right? So, um, or, okay, the other issue is, this is a very interesting issue. If you think about it, in other words, who does the requirements, who does the testing, and who does development? Usually, it's done by three different or different types of people, right? Usually, requirements are by the marketing, the business people, right? And then um, the testing is done by people who don't program, but they test software. They're good at testing software. Uh, and then you have the programs, right? Now, imagine we're spending, let's go back here. So while we're doing, let's say we're spending 3 months on the requirements, right? So what are the other people doing? The people who do the development or the design or development or testing, what are they doing? Well, in other words, we're spending 3 months, 6 months, a year doing requirements. What are the other people doing? Do we fire them or we don't hire them until we're done with the requirements? And then after we're done with the requirements, we fire the people who did the requirements because we don't need them anymore, right? So what do we do, right? If you think about it, it's an interesting issue, right? Right. I had a friend who worked for I think Google as a consultant, and he used to test the software. He told me like he was like, while they were going, even though they were doing, I think, iterative, incremental, but they took them like 2 weeks to do the iteration. So while he was waiting for them, he had nothing to do. He had nothing to test. So he would just sit around waiting for them to give him something to test. So, but waterfall, it's even worse because with waterfall, you could be waiting for a year or two, right? So what do people do? So how do you hire people? And then when you're done with their step, what do? You fire them? So it's very complicated, right? After you finish development, you fire all the programmers and then you just, you hire testers. Like, how does it work? Right? So it's a big issue. So so how do you schedule people? Um, how do you keep people busy, right? Because you don't want to pay for people who are just sitting around doing nothing. Um, so So these are the downsides of the waterfall, okay? Again, the scheduling issue. Then the most important one is number two, which is that if it takes more time to develop than you estimate, then that's it. You have to take longer to do it. Okay? Now, how does iterative help that? Does anybody know? When you do iterative, how does it solve this problem? the hard the project like taking too long to do or longer than we thought it would do. Yeah,
You get to know how long one part took, and then you multiply by the number of parts to estimate.
right, right, we're perfect, right. So we do is we see how much each increment takes, and we get a feel for how long things are going to take, right? Because we're doing all the steps, right? Right. So, we're going through all the, where's the model, right? Every time we, we, because we're doing a little bit, requirements, design, code, and testing every month, right? So, or every 2 weeks, whatever it is. But the point is, we're getting a good sense of what could get done. So rather than waiting for the third year, for like waterfall, waiting till the end and finding out that it's taking longer than we thought, we know ahead of time that we can't do everything we think we could do. And then if you know ahead of time that you can't do everything, so then you could start getting rid of certain features you don't really need, right? Like you could just do, if you realize it's going to take longer than we thought, so we'll just, jettison features that we could live without, right? Some things are like, you don't really require it for the first version of the software, you don't really need it to be there, right? It's just nice to have it, but you could live without it, right? Or 90% of your clients don't need this feature, so you could get rid of it, right? And then work on it later on after you complete the first version. But so this gives us a very good sense of how long things are going to take, right? And also, if you notice, everybody's going to be busy, right? We have every increment, everybody's doing requirements, design, coding, and testing, right? So everybody is busy, always busy, right? We're not letting people just sit around waiting for their turn, right? So that's incremental works out very well. And also, we could change since we're doing requirements at the beginning of every increment, so even though it's not great to change requirements, but we could, right? Because we're anyhow gonna get more, we're gonna like do a little bit more. So when we do a little bit more, we could change previous also because we're always repeating the requirement phase, right? So it's easier to make a change to the software, to the requirements, right? As opposed to waterfall where we're done with that stage, we're not going back to it. Over here, we're anyhow going to go back to the requirement stage. So once we're there, we could change previous requirements if we realize that it's better to make a change, right? Um, and then, so let's see what I wrote here. So that's basically what I wrote over here. Incremental also it's um, I wrote that it's similar to, this is what I am to think that way. So I'm a incremental person. So, so I don't know about you. Are you a incremental person? I don't know. Or you're like doing everything, you think about everything before you do it. Well, I'm an incremental. So I like jumping in and getting things, done without like, I don't like standing around thinking about it for a very long time. So, um, so that's one benefit for me. Um, it's okay. Two, we said I shouldn't say easier to make a change, but possible to make. Possible, uh, well, it's possible to make a change since we have new requirements each increment. Okay, it's still not good to make changes because when you make changes, then the previous code is going to get all messed up. It's never good to change, to make a change, but it's still easier to do it. Okay. Um, in other words, like you already wrote code based on other requirements. Now you're changing the requirements. So now, a good chance something is going to get messed up, right? Okay. But this is the main reason, right? That's what we said, is ability to estimate progress is more accurate. I shouldn't say estimate progress, or predict progress. Predict progress is accurate. Since we're actually developing and finishing features during each cycle, we can see how much, or increment, we can see how much how our estimates match our actual progress. Okay, so that's the main thing according to Uncle Bob, right? Is that we know what's going to happen in 3 years, right? We could say that based on the progress we're making now, in 3 years, this is how much with the current size of the team, this is what we could do, right? This is how much stuff we could do. Um, Number four is that, again, the idea of incremental is that after each increment, you have code which works, right? Because we're testing it. So since we have working code, after every month we have new we have our code is a little bit, but we add a little bit more code to the previous code, and so theoretically we could have people use it, right? So that would be, it's called early deployment, meaning that um, that as it's usable already, but we could give it out for people to use. Now, it's even that we don't do everything. Like, let's say we can only have let's say we're doing Microsoft Word, so we don't need. Let's say we leave out the mailings tab and the references tab and the layout tab. We still have something. It does something, right? You could still use it for something, right? Probably most people don't never use those tabs, right? Or Acrobat tab, right? So all these, so you could, so even though I have only part of it working, but whatever I do have is working, right? So I could release Microsoft Word, like it's not fully, it doesn't have all the features that we want to do, I could already give it to people and they could start using it, which is really great. As opposed to waterfall, where it won't be ready until everything is there, right? Because it's all built around getting everything, all the requirements finished, right? We're not trying to make it. We're only going to test it after all the code has been done, right? So that might, so if we don't, so there's no concept of early deployment, right? Because we're not going to test it until we wrote all the code. So it's impossible to deploy it, right? You can't deploy because you haven't tested it, right? How are you going to give it to people and it's never been tested, right? So so you have to finish all the coding before you do all the testing. So you can't do early deployment with waterfall. Um, and number five, I'm just going to leave that out. This is like a side idea. Um, okay. So what is the downside okay, so these are all the good things about incremental. What are the downsides? Well, the downsides are, number one, it is, again, we said that since we're adding requirements, or we might be changing them. So how do you have a contract, right? To reach an agreement, um, is difficult to um, agree to whether to reach an agreement, right? Because clients are not sure what they are agreeing to, right? Because it's vague. I shouldn't say not sure because requirements are vague. Requirements are vague and subject to change. Okay. Okay, that's one problem. Another problem is that the code, if we're going to be changing, in other words, if we do a little bit of code at a time, chances are we're going to we're going to have to change existing code, right? We're not just going to, I mean, in a perfect world, each increment we would just add code, right? But without modifying existing code. But in real life, you're going to have to modify code, right? So every time you do that, what happens to the code? It slowly degrades in quality. And when that happens, you have to basically, you're going to have to spend time fixing it up, right? Because every time you keep adding a little bit part, a little, another feature, another feature, another feature, you're probably going to have to start modifying, you have to constantly be modifying code, right? So, but the problem is it gets messy, right? When you keep modifying code. So you have to refactor, right? What does refactor mean? Refactor means to take working code and reorganize it in a clear manner, right? So it's clear what it does, right? Right, like for example, um, um, if you have a lot of if statements or weird if statements, so it's not obvious what the code is doing, and then when you make a change to it, then it's easy to cause a bug. So basically, you need to keep on your code simple and easy to maintain. Um, and then another problem is, in general, is that with incremental, we're always focused, everybody's thinking about what are we doing this increment, this cycle, right? And that's what the focus is on. So you sort of lose the overall view of the whole program. Does that make sense? Whereas if you're thinking about everybody's focus is getting, this 2 week or 4 week requirements finished by the end of the month, right? That's our focus. We're not thinking about the overall design of the program because we're thinking in small parts. So sometimes you sort of like lose sight of the forest because you're always looking at the trees, right? We're always looking at our own cycle of a small bit that we're doing now. We don't really we lose sight of like we don't think of like a we don't think of like something that might require, let's say, a 3 month um, you know amount of work. It's what we're thinking in small parts, but maybe there's something there's like a big part that we should do, right? Maybe there's like a big change that would, revolutionize how our program is going to work, right? But we're going to miss that because we're only thinking in small chunks, right? Like sometimes I'll give you an example, like maybe like maybe you wanted to work on um, like maybe you decide that you want to work with a different database, but that would take a couple months. It's not like it wouldn't be a small, it would require, let's say, you can't just change part of the program to work with a different database, right? You would have to change, you'd have to stop. Um, you wouldn't be able to test it. You wouldn't have anything for a month or for a couple months, right? Because that would be like a real major change. So, but you wouldn't think of that, even though it might be a really good idea, but you wouldn't even think of that because you're only thinking about things that only take that you could do in a month, right? But something that would require more than that, you're not going to think about, right? But it might be a great idea, right? Or you might want to port it to another platform. That might also, the code might be unusable until, for a couple months because there's so many changes you have to make to get it to go work on another platform. But we're not going to think about that because we're only focusing on the things that get done in a month. Okay, so that's a problem, right? That you might miss a really good idea, but because it takes too long. Um, okay, and then we spoke about the reuse model. We said it's always better in general. And then the downside, what could be wrong with a reuse model? Well, number one, it's um, well, it is what it is, right? It only does what it does, right? You can't customize it, right? If it, you're stuck with it, right? If Or number two is actually more serious, which is that the person who wrote the code sort of, they went on to do other things, right? Which happens all the time, right? People release code and then they get bored and they do something else, right? So what are you going to do though, right? You have code which someone wrote, but they're not doing it anymore. So, so what are you going to do? So, you sort of, so that's one of the downsides of using someone else's code, or let's say the company goes out of business, right? Right, you're stuck with their code, right? And but there's no one around to fix it. Um, and also, the third thing is more minor, which is that sometimes you want to own the code, all the code, and if sometimes if you other people's software, they have licensing restrictions, so you can't just sell it to other people without, whatever the restrictions are. So these are like the main downsides that I thought of with reusing code. Okay. Um, when I say limited, I meant that features are limited uh, to not but whoever to what the code does. The code is no, the code currently does, um, i.e., can't really modify make any changes, right? Right. Right, so that's very interesting, right? I mean, like we have software that's really not supported at work, and what we have the code for it. So we're able to make changes, but you know, it's a little bit scary because it's someone else's code and you have to understand what they're doing. So, but we do have the code. Um, But in general, when you're reusing code, you don't really want to change it. You just want to use whatever they gave you. Um, okay. Okay. So far we had the three models, right? Reuse, incremental, and um, uh, waterfall. Now there's one more, which I want to discuss. It's a form of the waterfall. Okay. It's easier to explain by looking at this picture here. So over here, we have a V. That's why it looks like a V, right? That's why it's called the V model. Okay. So the left side is basically the waterfall. So basically it's going downhill starts at the requirements, whatever, design, low-level design, coding, and then it goes back up to testing, different testing, blah, 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 right? So, um, how's this different than the waterfall, right? Because basically we're going in order, right? Right, we're starting here, we go all the way to here, right? Okay. So far it's really it's a V, but it's really a waterfall, really, because the V is really because you're starting over here, you're going down, and then you're going back up, right? So it really is a waterfall, right? So why is it called a V model? So the answer is that while I'm doing the requirements, I'm actually writing a test to go along with those requirements. While I'm doing, in other words, at each step going down the waterfall, I'm creating a test. So when I'm done with the coding, guess what? I have a lot of tests that I already wrote while I was doing these steps. So, so even though it looks like a waterfall, but the tests are all written while I was doing each step. So along the sort of like, like sometimes like when I try to do this, like when after every class, I think about, oh, the midterm or the final, and I try to like, you know, because if I write the midterm, like after in the middle of the semester, I'm going to forget what I did at the beginning of the semester, right? So, or I might, right? So basically if I write, but if after every class I write a couple questions, so then when it comes time to write the midterm, I already have most of the questions done, right? Because while I was teaching the class, I was writing the midterm, right, or the final, right? So for me, I don't, I try to do it, but I don't always, I don't, whatever. But I try to do that because it's much easier to write the midterm while it's fresh in your mind, right? Right. Like for example, I just taught the downside of the pluses and minus of all these different process models. So now it's easy for me to, and while it's in my mind, I could write a question in a midterm about it, right? So while something is fresh in your mind, it's easier to write a test, right? Rather than if you wait till the coding part is done, then you want to sit down. If then you're going to sit down and write the test, what's going to happen? You're not going to really remember. You might have done especially waterfall, you might have done the requirements a year ago and you forgot exactly what they were, how, the specific nuances. So, and you can be too lazy to go read through it. So basically, you're not going to have such good tests. The better way to do it would be is as you go through each step, you write as many tests as you could think of, and then when you're done with the coding, bang, you already have all the tests written, and you have to go through all of them. So the VMAL is a very interesting idea, right? Because it deals with human psychology because people are very lazy, right? And they think did I write this down here? People we feel that when we finish coding, the code is done. It has no bugs unless unless um, unless you see it, you see one, right? Right? So with the V model, though, we're going to write the tests before we completed the code and before we get that confidence that we've completed the project already. And the testing, it works, So because people think, oh, once I wrote the code, it's good. I don't have to test it, So or they'll do minimal testing. Who's going to know whether you tested it or not, if it works, right? Right, if something works, who's going to know that you tested and made sure it works, right? If it, so, um, so to get around the laziness, the V model is a great idea. It's a very cute idea. That's why I included it. Okay, so we're done with this, with chapter two. Okay, basically I just did, I just did like the idea of having a checklist that before you do operation, before you fly a plane, the idea is that just so you should have um, you don't want to do things without thinking about it, right? But I remember I was saying like if you have a job interview, you don't want to just like if someone asks you a question like how would you do this? And you don't just want to answer it, say, well, this is what I would do, because that means you didn't really think about it, right? And the sign of a good programmer is that they thought about the problem before they started the solution, right? So, so for example, if you have a job interview and they ask you a question, how would you do this? You would ask them, you probably should ask them a bunch of questions. Say, well, could you explain to me exactly what you want? Like, you want me to write a program that, what's the maximum number of whatever, you know, if they want me a program to sort things, right? Could it have unlimited sorting? Could the list be unlimited? Is it, is there a limit into the list? I don't know. Just think of things that might, that you need to know when you write the program, right? Um, could it run in parallel? You know, you know, it could just bring up different issues that you might think of, right? But the point is you're trying to show the other person that you think before you act, right? You don't just like, you know, how would you do this? Well, I would just write this and that and this, without, the first thing you should do is think about it. Well, you say, well, let me think about it. And then you ask some questions. Uh, maybe you would write down, take if there's a little whiteboard, you would write down, so we do this, and, you would ask like, um, what are there memory constraints or, stuff like that. Just things that you might, that might affect the, the program. The point isn't really the point is just to show the person interviewing you that you think about what you do, right? Just like over here, when you have like an airplane, you got to think about what you're going to do. You don't just go into the airplane, turn the key, and start flying, right? You got to go through the checklist. Or when you do an operation, you don't just, you know, go in and start cutting, right? You have all these things, the checklist you have to go through, right? So that's the idea of of using a process models to think about what you're going to do and then do it. Um, okay, so we're done with chapter two, and I'll upload that. Uh, did we do the observer pattern? I don't think we did we?
Oh, sure.
Let me just see. Oh, look, I'm pretty sure we did not. I was sure we didn't, but then I said, wait a second, maybe we did. And I'm nearly positive we didn't.
Is, oh, I probably just forgot.
Uh, I figure we'll do a little coding. Um, Let me just see that we did here. We did uh, well, we didn't do it in one, so uh, we would have done it. Let's see, did we do five? No, we did. Uh, no, no, we didn't do it. I don't think we did. we did the strategy pattern, I think, right? We did that for sure.
Oh, yeah.
Yeah, so that is, yeah, that's there. Right. So we didn't do the observer pattern. Okay. Okay, because observer pattern is it's sort of like the strategy pattern. Okay. It's actually is a strategy pattern, but it's a form of it, a special form. Like it's used so much that it has its own name. So let's just uh hmm. Let's just start with it, okay? And actually, um, okay, okay, actually, let's just look. Actually, maybe I'll do that. I'll show an example of the observer pattern in code. In this happens to be in C sharp. Um, I'll show you the observer pattern in real life, and then you could, I think it'll help understand when we do it. Okay, so if we look over here, this is a program. Let me just, error occurred. Oh, now it's doing something. Uh, actually, you know what? I'll do one from scratch. Okay, so I'll do a new, I don't know what happened. I would do, for example, let me do here really fast. A new project, and let's do a wind form. This is going to be C sharp. This is C sharp, and I'm going to move this out of the way. Okay, so I start out with I'm not going to do much code. There's not going to be a lot going on here. I just want to show you the concept. So I'm just waiting. Okay, so we have a button. I'm going to put a button over here. If you're not familiar, button is like I don't know. This is what a button looks like, right? So if I would run this, right, and I click this, it doesn't do anything, right? Because there's no code connected to it, right? So what I could do though is I could connect code that will be activated when this is clicked, right? Okay. So what I'm going to do here is I I'm going to put a message. Um, I work with this during the day, so I know this. Button one, click. I'll just put it here. Okay. So now if I run it, this code will execute. So if I do it like that, you see that pops up, right? Very simple program, right? Not too, not very, um, complicated, right? Now, what's interesting though is how does this work, right? How is this code that executes when I click the button, how does that work? Well, the way it works, okay, we'll see in a second, is that we have this uh, button one, which is the name of this button, has a click event, meaning that it has this, um, it sort of like has this, um, it, it sort of like has this, um, uh, like a list of objects, right? Which when you click the button, it's going to notify that there was a click. Okay? So let me repeat that. So when this button is clicked, right, there are going to be listen, it has a, there's a, in other words, in this code over here, I know it looks complicated, but it's not really that complicated. All that's happening is that this method, button one click is a method over here. See, it's just a regular method in .NET. Is this right? Is being registered with the click event. So whenever the click event is, whenever a button is clicked, the button says, is anybody listening to me? Do I have any listeners? Oh, I have a listener. I have this method that's listening. So I'm going to notify them that I was clicked, right? So basically, so I could, for example, I could have, um, I could have three, I could have this method added three times to button one click. So in other words, so every time the button one is clicked, it's going to call all three of them, right? Because they're all listening. Because I told the click that whenever you get clicked, let me know that you got clicked, right? So basically, and how are you going to tell me that you were clicked? Well, you're going to call me and you're going to pass these two arguments. You're going to pass um, the sender and this whatever these arguments, whatever they are. The point is that the button one every you know it's even though the button one is is being modified. You know, is the code for button one being modified?
Uh, it shouldn't.
No, it's not being modified, right? It's not being modified, but rather it allows itself to it's allowing me to give it methods and say that when you get clicked, please call me. Okay? I want to be, I'm like a subscriber to your click event. I want to be notified when you get clicked, right? So that's why, I did that three times. I said here, here, and here, right? This could be button two click, could be button three click, and then I could go over here and just create, um, I could just create these methods. Um, I could do button two click, button three click. So, so basically what I'm saying is that when you get clicked, notify these methods that you were clicked, right? Call them with this prearranged um, parameters, who the sender is and whatever this is. Okay, it doesn't make a difference what that is, right? But send in the button three saying, I want to be, please notify me. Okay. And so when button one gets clicked, it's going to go through all the listeners and it's going to call them and notify them that there was a click event. Okay. So basically, if we go over here and we click on the button, you'll have first button one, it's going to call button one, two, and three, right? Because they're all listeners, right? And they asked to be notified whenever there was a click, right? So each one of these are going to be called one time. Okay. So the idea is that the button one has a way that it allows people to listen to for different events. Like there's also a double click event, there's different events. But it has an architecture that allows observers to register with it and say, that I want to be notified when something happens, right? And then so even though we're not changing any of the button one code, right? But it has a facility to allow people to say, I want to be notified about something, right? It gives us, right, and well, without changing my code, okay, without changing the button one code, it allows other people to say, let me know when something happens. Okay, now we're going to do a completely different example, but this is how Visual Studio uses the observer pattern, right? So button one click and button two click and button three click, they're called observers, right? Because they're being they're being notified when they registered with the button one click, and they say when you get clicked, notify me because we want to know about it. Okay, so so in the design pattern language, these are called observers. Okay, and this is called the what's being observed, observable. Okay, so okay, we'll do the actual. We didn't really have time to do it. We'll do the actual observer pattern. We'll do it on this coming Tuesday, I hope. Okay, so okay, I'll see you. Okay, have a nice weekend.